Okay. 4.1, continued. We'll start with the higher derivative question, because that's sort of where we left off with. Okay. 2. Find f double prime of x. And I'm going to say that f of x equals, and I'll mix it up with the different types of exponents that we get. Right? So let's say minus 3x to the fourth plus 1/3 x to the -3. And then we'll do plus 8x to the -1/2. Okay. So we've got a positive integer, a negative integer, and a negative fraction exponent. And so the directions say do the derivative twice. Okay, so that's twice. Do the derivative twice. That's what the double prime means. Okay, so here we go. Here goes the first time. So single prime. Drop the power. Subtract 1. Drop the power. Subtract 1. Drop the power. Right, so I'm simplifying that in my head. 8 times -1/2. Subtract 1. Okay, that's the first derivative because I did the power rule once. Okay, now do it again. Okay. All right, same exact thing. Drop the power. Subtract 1. Drop the power. Subtract 1. Just be careful with the pluses and minuses. All right, watch those changing signs. All right. Okay. Yeah, I feel like I'm going to multiply this one over here. Okay, so that's positive 12 over, so 6. Okay, so drop the power, subtract 1. Whew. Okay, now that is the answer. Okay, I'm going to rewrite it just so that you can see what that would look like. Now, it didn't say rewrite it. It just said find the second derivative. Okay, now the other format is possibly, see that 5 is moving. Okay, the x to the 5th, 6x to the 5 over 2. So maybe you just write it with positive exponents. Maybe you turn this one into a radical. Okay, power root. Right. All of these things are the same. They're just written differently. This one has positive exponents. This one is fully simplified, which means that you write it as the radical instead. It just depends upon the directions, which one you pick. All right. Sure, we'll just do 3, okay? d dx root x plus 5 over 6 root x cubed bar x equals 3. You're like, that looks weird. It's the notation. It's not actually what we're doing. It's what the notation is telling me to do. So the first thing I'm going to do is sort of just identify what these different symbols mean so that I can interpret them. All right. So this part right here, right, that part means find the derivative once because it's d dx and it's written once. Kind of like the other notation. So this means find the derivative. That's what it means. Okay? Find the derivative of this thing, right? That's the y equals part. Find the derivative of this thing in the parentheses. And then the last part is evaluate for x equals 3. So you have a lot of steps here. You've got the find the derivative step, and you have the evaluate for 3 step. Okay. So I've translated the problem. I've figured out what I'm supposed to do. So I'm going to start by just writing y equals, right, x to the 1/2, so that I can actually do the problem. Okay, plus 5 over 6 x to the 3/2. Okay. I'm going to switch colors because I'm ready for the derivative now. Y prime equals. All right, let's do volunteer. Just how do I do the power rule? Yeah, Adam. Yes, awesome. Okay. And the second part, who can give me the power rule step for the second part? Yep.
It's going to be 15 over 12, I think.
Yes. Does that reduce at all?
5 over 4.
Yes. Okay. So 5 over 4 x, and then what's my new power?
1/2.
Perfect. Okay. Here we go. 2 new people. How do I write this without the negative fraction exponent? Yeah.
1 over 2 x to the
Yes, square root of x. Awesome. Okay. The next part. All right, hold on. Let's see if somebody. A new hand. Yes, Pedro.
5 over 4 square root of x.
Okay. So where does my square root of x go, with the 5 or the 4?
With the 5.
Yes. Okay, awesome. Right, because this exponent's negative, so it moves to the bottom. This exponent is not negative, so it stays on the top. All right. So we've done the first step, right, where we figure out what my y equals. We've actually done the derivative. Now I have to plug in 3. Okay, so I'm just going to come up here and do it in the second column. So y prime of 3 equals 1 over 2 root 3 plus 5 root 3 over 4. Boom. The directions say simplify it, put it together. So I need a common denominator. Yeah, Algebra 2 and Frico. Okay. A hand I have yet to see, right? What am I going to do to get a common denominator? Yeah, Ben?
You can multiply. So I said multiply 2 by the first one and then
root x by the second one.
Yes, okay. Oh, that was awesome. So we're going to multiply 2 here, and instead of root x, because we already have the root 3 there, we're going to multiply the root 3. That's fine. You can do it with x's. We already have the number, so I'll do it with the number. All right, I really like that choice because I did not multiply by 4. I didn't choose times 4, and I didn't choose 2 root 3. I didn't just swap the denominators. I looked to multiply by the smallest quantity possible, so that was a great choice. Okay, so we get 2 over 4 root 3, and then we get 5 root 9. 5 root 9 over 4 root 3. Okay, so this is 2 over 4 root 3 plus 15 over 4 root 3 equals 17 over 4 root 3. Yes, you can leave the radical in the denominator. That is okay. Okay, that is what the question in Delta Math is asking you in the level 3, where you've got to do the derivative, and you're going to have radicals and reciprocals. And then you have to plug in, and you're going to have to deal with this common denominator in order to get the combined answer. Okay? Okay, 4.2. Tangent lines. Okay. A. Just going to look at tangent, line, and slope. So all I'm really going to do here is just write the equation of a tangent line, just so that we can look back and reference it. Okay, so we have y minus y1 equals tangent slope x minus x1. Okay, that's the equation of a tangent line. The only thing that makes a tangent line is the tangent slope. Okay, so we have a point which is typically x comma y. That's the x1 and the y1. That's the actual point on the original graph. And then we have tangent slope. Okay? Tangent slope comes from the derivative. Okay, so it's a little bit of vocab. So here we go. Example. All right, if you guys can do this before I do it, I will cut off example number 2.
You gotta hit the start.
Oh yeah, I'll write it and then let you work. Okay.
We'll make an example, so.
Find the equation of tangent line at x equals -1. Okay, and here is your equation. Right. Okay, so I took f of x, and to find the point, I plugged in -1. So my point is -1, -9. Now, tangent slope. Tangent slope comes from the derivative. So I'm going to do the power rule. Y prime equals 12x squared minus 6x plus 2. And I changed colors so you could see that I was doing the derivative. Now this part, x is still -1, guys. And the x coordinate's not changing. Okay? So if I plug this in, okay, so we get 12 plus 6 plus 2 equals 20. Okay, so y prime of -1 equals 20, which means this is the tangent slope. Look what column it's in. It's in the tangent slope column. Okay, so I've got my two numbers. Y plus 9 equals 20, x plus 1. Okay. Okay, same question. Because I saw a lot of you got it, but there was definitely a handful that needed that example. So equation of tangent line, okay, at x equals 1, okay, and we'll say that y equals negative 2x to the 4th plus x squared minus 4. Okay, same question that we just did. Okay, equation of tangent line. So leave the work there, and I will give you 2 minutes. I'll start the timer after you write it. Thank you. Okay, 45 seconds. Did you get it? Yeah. Good. Yeah. Yes. Yes, yes. Yes, these are the right numbers. This should be this line. All right. Yes. All right, y plus 5 equals -6, parentheses, x minus 1. Yes, awesome. Okay. Yes. All right. Okay, 2 new questions. It's actually 1 question, but we're going to do it twice. And then it's game day. All right, here we go. I guess I'll write my answer here. So we have a point, and we have a tangent slope. So this has to be the y prime plus 2x. And then I have to plug in the 1, okay? So that gives me -8 plus 2. So negative 6 is the tangent slope. The point comes from the original equation. So I plug in 1. Okay. So I get minus 2 plus 1 minus 4 is negative 5. And then I sneak in y plus 5 equals tangent slope x minus 1. There you go. Okay, keep in mind we have 2 columns, right? We have points that come from the original, and we have tangent slopes that come from the derivative. Here we go. At what point is the tangent, I got you, tangent slope 48? Okay, so I want to know, where is the tangent slope 48? Okay, here is your equation. Y equals 2x cubed minus x squared plus 3. So before I start trying to figure out what to do to answer this, I'm going to think of it visually. That is a cubic graph. It's a cubic graph. So let me draw a cubic graph. I mean, I could also put it in Desmos and look at it to see like exactly what it looks like, but that's a general cubic graph. And I think that there's a positive slope over here that could be 48, and maybe there's a positive slope over here. So just visually, I think there's supposed to be an answer to this. Okay, so we have 2 columns, right? Because we're talking about tangent slopes, and we're talking about points. So we have a column for points on the graph. And underneath of this, I'm going to write 2x cubed minus x squared plus 3. Because the original, that's the thing that points on the graph come from. And then I'm going to switch colors. And I'm going to have a column for tangent slope information. Tangent slopes come from the derivative. I haven't even tried to answer the question. All I'm doing is writing down the information from the description. Okay? Now there's one more piece of information that I know. Okay? I've got the original. Great. I've got the derivative because I can do the power rule. Anything else that I can write down from the question?
Slope is
Yeah, what's the slope?
48.
The slope, the tangent slope is 48. Notice how I put it in the tangent slope column? And notice how I didn't write x equals 1 or 2 anywhere because I don't know what x equals. All I know is this. Okay. This is where it becomes a little bit mathy. Okay? What are you going to do to put this information together? That's where we're at. You have to put it together. Which piece has more information? The blue or the red? The red. Okay, so maybe I'm going to start over here with the red information because there's more of it. Kind of looks like a system of equations. Could I just set them equal? A lot of things in calculus turn out to be a system because you've got multiple pieces of information that you put together. I had 2 pieces of tangent slope information. 2 pieces of information put them together to solve. The tangent slope equals 48. The derivative, which is also tangent slope, equals 6x squared minus 2x. Put them equal, right? Y primes, they're the same. All right, so this is a quadratic. In case you want to know how to solve a quadratic, there's a poster on the back right that says how to solve a quadratic. Okay, I'm going to start by dividing everything by 2. Okay, and I'm going to try to factor. Okay, so I've got my factors. So I end up with those two x coordinates. My picture kind of tells me that I should be expecting 2 places on this graph to have a slope of positive 48. I got 2 x coordinates. Okay, well, it's asking me at what point. That's x comma y. Points are x comma y, which means I need to come over here. These are the x values where the slope is 48. That's what you put together. That's what you solved. You found the x's when the slope was 48. So now we have to find the corresponding y value. Okay, so I get the point 3 comma 48. Okay, there's 1 point. How do you get the other point? Negative 8 over 3. Plug it in. Okay, I'm not going to do this one by hand because it's kind of tedious. I'm just going to write it down, and then I will evaluate using a calculator or Desmos. So I'm going to open up Desmos because it's easier to type in there. Okay. Okay. 2 negative 8 over 3. Cubed, okay, minus negative 8 over 3 squared plus 3. Anyone know how to, oh, there it is, fraction? Haha, fraction button. Perfect. So y equals minus 1135 over 27. Okay, so here's my other point. Guys, use a calculator to help you with the arithmetic. I do not need you to do it all like by hand. Okay, there's way too many steps of setting up to make arithmetic the part that gets it wrong. Okay, so use additional things to help you solve. Now, just as a general check here, I'm going to put this question in. Okay, so y equals 2x cubed. Because I'm kind of curious, x squared plus 3. Okay, so right here, let's see it, x equals 3. Let's try this. F of x. F of 3. Okay, so that's a point right there. So let's look at the point, 3 comma 48. Label it. Okay. There it is, it's way up here. The slope of that dot right there should be 48. No, 48 should be, yeah, 48. Oh, it actually happens to have the same y coordinate. Didn't even notice. Okay, now look at this. The same thing should happen over here. Over here. Okay, look at what we did. We took the information and we put it into 2 columns. One about the original, one about the slope. If you have 2 pieces of information, put it together and solve. Notice how I kept the things in columns. Everything about points was on the left. Everything about the tangent slope was on the right. Okay, here's your last question. I'll make the algebra a little simpler. Okay. This is it, and then it's game day. Okay. At what points is the tangent slope equal to 5? All right, so right, much smaller number. Okay, here is your y equals. Okay, so you've got points and you have tangent slopes. Start dividing up the information into which column it goes with. Just dividing information up. Okay, that's everything I learned from the problem. The only piece that has more than one thing to work with is tangent slope. That creates a system for you to solve. Okay, so you set them equal, right? Because both things are tangent slope. Minus 3 equals, oh, that's positive, okay? So x equals negative 3 over 2. Okay, I found the x coordinate. I found the x coordinate. So I can take the x coordinate and bring it over to the other column. The x's match on both sides, right? X equals 1 when we did our tangent line. We used x equals 1 on both sides. Okay, so x equals negative 3 over 2 means I can use it in this part here.
So is the point negative 3 over 2 and 5?
No. The tangent slope is 5. 5 is not part of the point. The tangent slope is 5. So if I want the y coordinate, it's got to come from the first column. minus 9 over 4 minus 3 plus 1. So negative 9 over 4 minus 2. Okay, so the point which came from the first column is negative 3 over 2, negative 17 over 4. And if I think about it, this is a concave down, that means opening down like a frown, parabola, and it has a positive 5 slope in what I think is one spot. I found one point. And I could put that graph in Desmos and actually look at it to see if it matches. But just visually, I think I got it.